channel. On this episode, we're going to do something a little bit different. We are going to start a separate series and we are going to be working on carbon fiber composites. So if you guys are familiar, this is my truck build. It is a 1992 C1500 pickup truck, and we're doing a full custom chassis build, twin turbo, Gen 5 motor, the whole 9 yards. This build so far has been mainly focused around automotive fabrication, you know, sheet metal work, stainless work, turbos, that kind of stuff, as well as the chassis build itself. But we're now delving into the world of composites. So I wanted to separate the series out and sort of make a separate playlist for you guys on the YouTube that deals strictly with what I'm going to be doing with the composites. This build series on the truck will still be going on. You can see it up here in the card at the top right. But I think that the content that we have coming up is going to be a little unique and doesn't really necessarily match what we're doing here. So without further ado, we'll get started on the video. But first, I wanted to tell you a little bit more about the project. The project that we're working on is we're making a set of carbon fiber valve covers for this motor. It is just the first project that we're going to be working on. We're going to be doing a fair amount of composite stuff on this, hopefully, as long as this goes well. And I wanted to talk a little bit about carbon fiber and an application like this for, you know, something like a valve cover. I've had a lot of guys reach out through Instagram or Facebook to tell me, hey man, you're going to run into trouble with this. You know, this isn't a good application of carbon fiber. And I've had these, they've leaked, etc. And I understand that. So a lot of the commercially available stuff has some issues with leakage and stuff like that. But I'm doing what I can to address those problems, and am working with some pretty high-end engineering vendors to try to come up with solutions to the current problems with this sets of valve covers. Does that mean that I'm going to be successful and make, you know, a set of valve covers that are perfect and don't have the issues of some of the other stuff on the market? Maybe not. But I'm willing to try, and I'm going to give it a whirl. Working with some different composites experts from 3M and from PDR Resin Technologies to work up a solution. So that stuff will be coming up in future episodes. This episode is mainly going to be about building the plug for our design. I just wanted to say something up front, because I know a lot of guys are going to reach out to me and say, hey, you know, you're getting in pretty deep here, and I might be. So I'm okay with that. If they fail and they leak, I'll swap them out and put aluminum valve covers on, but it's worth the exercise here on something. I want to learn how to work on composites and do composites. So I want to try something, and I understand that this may not be the most simple starter project, but I'm okay with that. So this was also the first thing I ever welded, was this chassis, more or less. I made the fabrication table over there, and I started building a chassis. So this isn't necessarily the most simple thing to start your fabrication career on either. So I'm okay with the challenge. So without further ado, let's get to the video. Okay, so first things first, for our carbon fiber valve covers, there's a couple things that we are going to do. I am going to use these ICT billet spacers that are actually for an LTX application, and they're meant for like spacers if you want to run roller rockers. We're going to use these as our flanges. Since we are going to use these as our flanges, we need to get a good, accurate model of these into the computer. So what I did in order to do this is I scanned them on a computer scanner. So I just laid them up on a scanner with a 1, 2, 3 block, scan them in thirds, and then splice them all together. So here's a picture in the video here of basically what that looks like when I splice it all together. And so what we did after we spliced that all together is we put it into CAD, and since the scanner takes a really nice 2D image and there's not a lot of parallax error or anything like that, we can basically trace right in CAD our dimensions back into the CAD drawing. So what I did is, the first thing I did is I made a direct copy of the spacer and just printed out some thin material here on the 3D printer to check to see how our fitment is. And if you look, the fitment is amazingly good. So it is a very true copy of the part. So the scanner works impeccably. So what I'm going to continue to do here, I'm going to print out the rest of these, tape them up, make sure that all of my spacing is correct, all my bolt holes line up, everything is good. And then we're going to move on to the next part where we are going to make a plug for our carbon fiber mold. Before we do that, I want to explain just a little bit about how this is going to fit together. So this flange is actually going to be completely covered in carbon fiber. We're going to have the upper part of carbon fiber here with a flange that extends down over and fits to this outside edge here. And then we will basically come over top of this with the carbon fiber, and we'll extend past it for a while, and we'll epoxy this flange down into our carbon fiber part that we make. So because of that, this flange will be slightly smaller than our carbon fiber. My goal is to make the carbon fiber 1/16 of an inch thick. So what that means is that the plug that we make will be 1/16 of an inch oversized in all directions to this part. And then we will make sure that our thickness on our carbon fiber is close to 1/16 of an inch, maybe slightly under. And that will give us just a little bit of epoxy gap for fusion onto this flange when we go to bond the flange to the carbon. Okay, so here's our first section of our 3D printed plug. This is about typical, the finish that I'm getting. I'm getting a little bit of like little boogers and stuff like that, but they pop off really easy and clean up with sanding. This is wood filament. So there's a 20%, I believe it's bamboo powder fill in the PLA filament, and that gives it a little bit better sandability, and it doesn't tend to sort of gum up when you're sanding it. So I did make this one. This is the first working one. This is a test piece, and it's only a test piece because I screwed it up. Originally, when I scanned these parts, I scanned it with the gasket down, and when I modeled it right off that surface. Well, if you think through that, that's not good, because that means that this is on the wrong side. If you flip it over, it won't fit. These are not symmetrical, so I can't just flip it over and, you know, put it on this side. So this is a junk part here, but you can see I just hit it real quick with a sander, and it cleans up the edges pretty good. There's still a little bit of surface texture, but it knocks off the high spots. So what we're gonna do is we're gonna continue to print the rest of the sections out. There'll be 3 sections, and then we'll bond them together, sand them, and then once we're done sanding them, we'll add some body filler, fill in the low spots, keep sanding, yada, 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 and then we'll show you what the next steps are after that. Okay guys, so I'm down here in the basement working on the reloading bench. I got the first 2 pieces printed out, and I just glued those together. I'm using like an instant style epoxy. Squeezed them together as tight as I could, and then held them down with some clamps. So this is going to set up for probably a good 8 hours or so. And then by that point, the 3rd piece should be done, and then I'll glue that piece on as well. But so we'll get this done. You can see here the second part, I got a lot of like porosity and crap, but that's going to be fine. We're going to sand this all out, fill all the pinholes, do the high build primer, all that fun stuff. So we're not really worried about it, but it is kind of annoying. So I try to work on dehumidifying the filament and getting the filament in better shape for the next one. We'll see how it turns out. Okay, so this is the 3rd piece. I actually ran out of filament at the end, so I just finished it up with some PLA. I'll have to be kind of careful when I'm sanding it, but you can see the surface finish is crap. So this definitely was degrading over time. You can see the first print, then the second print, and then the 3rd print. So I'm thinking what happened was this is all moisture in this filament. So this is the first time I've used wood infused filament. I dehydrated it for 8 hours the first time. Tried it out, seemed fine. Tried dehydrating it about an hour and a half after we printed this one, and frankly it just didn't come out that great. So not sure what's going on. It seems like the PLA prints fine, so I don't think it's necessarily print settings. So what we're going to do in the future when we do this stuff, I'm just going to switch over to PLA. If you follow guys on Instagram like you know, Throttle Stop Garage or 3D Magic Mike, those guys all make 3D printed plugs and stuff like that. They seem to be using PLA. So I thought that the wood would be a little bit easier to sand, which it probably is, but I don't know if I want to put up with this crap. So I'm gonna go ahead and get this guy glued up, and then we'll show you what the process is for getting these plugs sort of blocked out and finished up. Okay, so I got the 3 pieces all glued up, and what I'm gonna do now and have been doing is sanding. So I got some 60 grit on just a random orbital palm sander, and I'm just gonna start roughing down all the high spots on this. With 3D printing, you don't want to go for the low spots because you got to remember how these things are built up. Primarily, if you have any voids, it's going to be a low spot. So we're just going to take it down until we get the surface smooth, and then what we'll do is we'll glaze this all out. But I just wanted to kind of show the difference. So I told you guys I ran out of filament. This is how the PLA sands it. It doesn't really cut. But if you look at the wood filament cuts damn near like wood. I'm actually pretty impressed with it. It's perfect for this application. I think now that I was having my doubts while I was printing it, because it does seem a little bit more difficult to print. They do get some more gaps in here and stuff, but the sandability of it is a lot better. So you can see it actually cuts just like wood, and you get wood dust everywhere, but it seems to be cutting a lot easier. So I'm not gonna videotape me sanding. You guys know what sanding looks like, so I'm just gonna sit here, get this whole thing whittled down until I'm happy with the finish, and then we'll go from there. But yeah, definitely the wood filament seems to be sanding pretty nice. Okay, so I got this thing rough sanded out, and there's some porosity and all sorts of low spots on it. So what we're gonna do is we're going to use some glazing putty. This is just standard automotive polyester glazing putty. This is a icing brand. I think it's USC, which is like a Valspar company. So we're gonna use that and mix some stuff up on our mixing board here. This is just one of those auto body tear off sheets that you can use, and we're just gonna glaze this entire surface. So just gonna take our time here. I'm gonna work up small little batches and actually spread it. Sometimes I'll spread it with this on the larger sections, but a lot of times I'll use like a razor blade like this and get some real fine sections, and I can really feather it with this. So our goal is just to fill everything in, and then we'll block this out, probably glaze it a couple more times, block it out, and then keep going and get it ready for surface primer. So there's a lot of work that needs done on this part, a lot of inclusions that need to be filled. So we're gonna start with this glazing putty and get it kind of ready to go. So this is a really lightly sanded or easy sanding product, and you can spread it exceptionally thin. So it spreads pretty easy. It's a little bit easier to work with than even like a plain body filler. That being said, you don't want to run quite as much thickness, but this is dimensionally close to where we need it. We're just trying to fill inclusion. So this should be the perfect product. So let's get started. So not gonna lie, I'm out of practice. I haven't done body work in like 10 years. Got a little thicker than I wanted in some spots, but they'll sand off super easy, so I'm not too worried about it. We'll go ahead and block what we have glassed out now. And then once I get this plastic off it, we'll keep working our way into some of these more delicate areas. But first I just wanna get everything sort of blocked to a nice even surface and sort of see what we're working with. So I forgot how runny that icing is. It spreads super thin, spreads super nice, but it is runny. So you have a tendency to, be working on stuff and get a little sag and stuff like that on more complex surfaces like this, but not a big deal. You knock that down with like 120 grit, a couple swipes, and it's gone. So it's really not that big of a deal. It's not like a heavy chop fill or chop strand body filler or anything like that where it's sort of a pain in the ass to sand. This stuff shaves off super easy. So I'm gonna leave this out here for tonight. I'm gonna call it a night. And then tomorrow, when this hardens up, I mean, it's already probably ready to sand off some of this older stuff. We'll knock this down and see what we got. Okay, so I started blocking this out and I started having some trouble getting down in these little corners here. So what I did is I went and I 3D printed a sanding block. So this sanding block has the same radius that is in these corners, and that allows me to get nice and tight in here. And the angle is set that I won't dig into these flat surfaces. So I'm gonna keep sanding and going along, but you can see already that we have knocked a lot of the porosity out, and we'll have to get us a second coat of glaze here and do the sections we haven't put a coat on yet, but looking pretty good. I forgot how bad this sucks. So I am sanding, making some progress. Things are looking pretty smooth. One thing I will say is try to avoid internal compound corners like this. That always sucks because getting down in these little radii is really tricky. So my fingerprints are just about gone, so that's good. Now I gotta get these guys cleaned out. I haven't even touched these yet. They still have a ton of filler in them. But overall, it's looking pretty good. So this might be ready for like the first coat of Surfacer here after this. I don't think I need to put any more filler in it, but we'll look over everything and give it a good check, look for pinholes, stuff like that, and go from there. But so far so good. Okay, so 10 hours of labor later, we are pretty much where we want to be. So I got probably 4 hours of sanding and filler work on this, and probably, well, another 6 hours of sanding the mold, you know, the plugs down, the 3D prints down, and I think it's pretty much ready to go. So what I'm gonna do next, before we actually go and spray the surface primer or the surfacer on it, I'm gonna go ahead and cut out a piece of 18 gauge steel, and that's gonna serve as a backer, and we're gonna make that pretty large, and that's gonna serve as a little extra surface for us to add flange material into our fiberglass mold. The flange material, that is really important because you need that to make sure you can get your sealing tape on and all that good stuff when you're working on the part in carbon. So I'm gonna go ahead off camera, get that cut out, and then I think for now what I'm gonna do is I'm just going to epoxy that down on to the steel, and then we'll go from there and get ready to spray some surfacer. Okay, so last night after the last vid, I went ahead and epoxied the part down to the steel plate here. This is 18 gauge steel plate, just roughed up with some 220 grit wet sand. Right now, the room, I have the heaters on. The room is about 75 degrees, so it's a little warm. Typically, you want to shoot between 60 and 80 degrees for this Duratec primer. This is Duratec 707002, and we're going to be mixing it about 2% mixture with a MEKP 925 hardener. So we're going to mix that 2% by volume and spray it. So temperature is good, but what I'm going to do is I'm actually turning the heaters off while I'm spraying because this is very flammable, and we're going to have a lot of atomized flammable vapors in here, and I prefer not to burn. So got some PPE, new vapor cartridges for this guy. I got a Tyvek suit that I'm going to be suiting up in, and we are going to spray this Duratec primer. So I'm going to mix up about a pint, and we are going to load it into this gun. This is just a super cheap Harbor Freight 1.4 millimeter tip. This gun has been modified to a 2.0 millimeter tip. It's just basically drilling out the tip and lapping the needle in there so it seals appropriately. I just have a cheap desiccant on it, and I did prep the air conditioner by draining all of the water and air completely out of the air compressor, drying the desiccant filters, cleaning the all the filters and stuff, and then refilling the compressor. It's good to refill the compressor because it's cold outside, so the relative humidity is pretty low, and the room is hot, so that drives the humidity in here down even further. So the humidity content inside of the compressor should be about as good as we're going to get it. That way we don't overwhelm that desiccant or this desiccant here, which is fine. So without much further ado, I'm going to get started mixing this up. I'm just gonna shoot this in a hyperlapse because once I get going with this, I gotta get moving. As soon as the hardener hits this cup, I need to mix it up, shoot it, and have everything shot in under 10 minutes. About 10 minutes, I'd say. And I need to start cleaning the gun. So if you look, I actually have some acetone in a cup ready to dunk the tip and stuff in. This is a $15 gun, so if we screw up, it's whatever. It's cheaper than a 3M gun with the consumables. It's cheaper than the consumables on one of those 3M gel coat guns, so it's not even a big deal. But we will try to clean it. So I'm going to set up the tripod. I'm going to pour this out. We are going to get it mixed up, and we're going to start spraying. So wish me luck. Brief correction before I get going here. It is 2% by mass, not 2% by volume. So I was thinking about that. I was looking at the scale and I'm like, man, 2% is not a lot. And I was going to try to figure out the densities to calculate it into weight because it seemed a more accurate way of doing it. It is 2% by weight from the get-go. I was wrong. So let's get started. Okay, so I wanted to give you guys an after action report. So this is the texture that you get with the surface primer right out of the gun. This is pretty typical, evidently. It's a heavy product. You know, you're doing a high build. There's probably, 500 to 800 mils or microns of surface finish, almost 30 to 40 mils. So that's what this looks like before you start wet sanding it. The nice thing about this product though is it wet sands very easily. So this is just a quick block with a 220 grit wet. And you can see we are starting to already get through the orange peel and getting the surface leveled out. So there's a good bit of fill here. So I'm going to slowly work this down. We put a good start on it here with the 220. I will probably slow down here a little bit and start feathering out this little bit of low spots here with some like 325 or something, 320 grit rather, and then just keep working this section down. There is a little tiny spot right there. I'm not sure if that was in the mold or if just like a divot in the finish, but I'll keep working this out. Hopefully we can get the whole thing blocked out and we don't have to reshoot. If we cut through, we may have to reshoot, but hopefully we have enough material in here that we can get it all blocked out nice and I don't cut through the edges. So I'm going to start working on this, wet sanding. We're gonna just go 220 for the rough to knock the orange peel off. Then once about 25% of the orange peel is left, I'll start moving into like a 320 or 400 grit wet. And then once all of that is gone, we'll move to like an 800 and 1000. And then it should be pretty smooth. So I'm gonna go on it. Okay, so before I get all the way through this, I want to show you sort of what I'm doing. So the flat surfaces I'm taking to probably about 30% orange peel left. This one here needs to go a little bit more. This one's just about perfect. The plate here for the flange, I'm not going too crazy with it. You can see there's orange peel still floating around the low spots here. This surface is just for the mold. I just want to make sure I knock off the majority of the texture so I don't have any mold release issues. All of these surfaces in here, what I'm doing is when I'm sanding it, I'm trying to focus only, I'm actually using my finger here when I'm sanding it, and I'm trying to only put pressure in the centers of these flat spots and trying to avoid touching the edges. So you can see a good example of this. There's an edge here that's completely untouched. And what the goal is by doing that is you don't want to sand through. So this goes for, you know, clear coat sanding or anything like that. It's a good idea just to not sand your edges. Go up to the edges, but don't cut over. And you'll see that even if you try that, you will feather, you have a tendency to feather the edge. And that's okay as long as you do this. I've painted, probably like 5 cars now, cut and buffed a whole bunch, you know, so I'm relatively comfortable with this technique. This orange peel will go away as we move up in subsequent grits. And then when I start getting into like the 800 territory, maybe 1200 territory, that's when I'm gonna start working these edges out and blending the edges. I'll start doing that with the 1200. The reason you do that is these edges are raised, so you're gonna get pressure spots underneath your sandpaper as you're sanding, so you're going to be cutting much more aggressively. So by the time you get to 1200, you're fine. You can keep wiping, checking, see what you're doing, and go from there. I will say this Duratec stuff's really nice because it has a really good sort of waxy eggshell sheen to it when it's unsanded. So like this is an unsanded section, and you can see it's sort of got a texture, and it really goes to a nice flat gray when it's sanded. So you have a nice contrast. You know, some of the like white products or even like the beige primers, you have a harder time picking up your orange peel. Here it's spot on. You can see it super easy. So I'm gonna keep sanding. I'm gonna keep going with this. Just wanted to take a brief stop and show you sort of the technique that I'm using for you guys that might want to try this and don't have the background in, you know, body work. Okay, so there we go. We got everything wet sanded, about 2000 grit. I did have some light sand throughs here on some of these edges. Not the actual radii, but the flat surface here on some of these protrusions for the bolt bosses. Got a little bit thin probably on the spray because they are sprayed at an angle. So they probably didn't have enough mill thickness there. I do not think that we need to spray, respray those. They're very, very faint shadow. You can just start to see where we're going through. So I think that with the PVA coating and stuff like that, we don't have to worry about any gel coat bleeding into the pattern or anything like that, or the plug. So what I'm gonna do now is I'm gonna Windex this thing, get it all cleaned up, get all the residue from the soap sanding off of it, and then I'm gonna get out the polisher and start buffing it up. So there you go, guys. That's a almost finished plug. Between now and the next episode, I'm gonna go get some coarser polishing compound and take it down to coarser polishing compound, then bring it back up. I had only some fine stuff here, so it didn't come out quite as deep of a finish as I'd like, but I mean, I'm happy with the way this turned out. So that is gonna be it for now. I'm going to let this mold sit and outgas for probably a good 2 weeks here and make sure all the solvents sort of cook out of it. And then we're gonna go ahead and proceed in our fiberglass mold on the next episode. So I hope you guys like this stuff. You know, it's something new for me. I'm learning as I go, but I'm pretty happy with the progress and results so far. So on the next episode, we'll make a mold.